welcome. In this video, we are required to find all the mesh currents in this circuit. Let's get right through it. The first thing we want to do is that we want to assign mesh currents to all the meshes. So if this is our mesh 1, the current in it would be I1, and with mesh 2, the current in it would be I2. Mesh 3 would have a current of I3, and mesh 4 would have a current of I4. Okay, now there are a couple of things we want to notice here is that this branch has a current source, this branch also has a current source. So we can join these two into super meshes, we can also join these two into super meshes. In short, we can join these three meshes together into one gigantic super mesh. Before we proceed to writing one big super mesh equation, let's first of all figure out the relationship between the currents in each super mesh. So we have mesh 1 and 2, and we realize that mesh 2 is supporting this 5 ampere current source and mesh 1 is opposing it. So we can say that I2 minus I1 is equals to 5 amperes. Let's call that our first equation. We can then proceed to this mesh, and we can see that I2 is supporting this current source and I3 is opposing it. So we know that I2 minus I3 equals 3I naught, and let's call this our second equation. Now, what is the value of I naught? We see from here that this is where I naught is, and I naught is directly opposing the 4 ampere the I4 the mesh 4 current, sorry about that, the mesh 4 current, and for that reason I naught has to be the opposite value of the negative value of the I4 current. So we know that I naught is equals to minus I4. We can then put this in the equation, and we will know that I2 minus I3 plus 3I4 equals 0. We can call this a third equation, although it is just a simplification of the second equation. We can then go ahead to write a super mesh equation, a KVL equation for this super mesh. Now, the mesh would look something like this. It would look something like this. So say we start from here. The current flowing through this is I2. So we would have so let's call the mesh SM 1, 2, 3. So we would have I2, 6I2. Okay. Then we come here and would have I1 flowing through this resistor. So that would be plus 2I1. We come here and would have I3 flowing through this 4 ohm resistor. So that would be plus 4I3. We come here and would have I3 minus I4 flowing through this 8 ohm resistor, and that will be plus 8 into I3 minus I4. Then we equate it all to 0. Then simplifying this further, we would have it that 2I1, okay, plus 6I2 plus 12I3 minus 8I4 all equal 0. We can call this a fourth equation. So we need one more equation from this mesh in order to be able to find the values of our mesh currents. So if we write the equation in this mesh, so we'd have 2i4 plus 10 plus 8i4. So let's call that M4, mesh 4. Now 2i4 plus 10 plus 8i4, sorry, i4 minus i3, i4 minus i3, must made that mistake, all equals to 0. Expanding that, we would have 10i4 minus 8i3 equals minus 10. And we can call this our fifth equation. Then we can simplify further. In a bid to do that, we can say that I4, that is looking at this equation, we can say that I4 is equals to 8i3 minus 10 divided by 10. So we can then go ahead and substitute this in the fourth equation, and that would get rid of the I4 current component of the equation. We can then solve it simultaneously with other equations. So by substituting that, we would have 2i1 plus 6i2 plus 12i3, okay, minus 8 into 8i3 minus 10 divided by 10, all equals 0. We can multiply through by 10. If we do multiply through by 10, we would have 20i1 plus 60i2 plus 120i3 minus 64i3 plus 80, all equals 0. We can then simplify further and would have 20i1 plus 60i2 plus 184. That would be minus 56 plus 56 plus 56 I3 plus 56 I3 all equals 80. Let's rewrite that for clarity. 20i1 plus 60i2 plus 56i3 equals minus 180. We can substitute this same equation into equation 3 to get rid of this I4, and we would have I2 minus I3 plus 3 into 8i3 minus 10 all divided by 10 equals 0. Multiply through by 10, we would have 10i2 minus 10i3 plus 24i3 all equals 30. And that would further simplify to 10i2 plus 14i3 equals 30. And call this a seventh equation. We can solve this equation, and this equation simultaneously. First equation, seventh equation, and sixth equation simultaneously, and would have I1 would be equals to minus 7.5 amperes. I2 would be equals to minus 2.5 amperes. I3 would be equals to 3.93 amperes. And I4 would be equals to 2.144 amperes.